In the previous videos, we have been talking about simulating annealing, and we have seen an example to how to find the global maximum or the global minimum for a one-dimensional function. Of course, we use simulated annealing for much complex problems, such as, for example, NP-complete problems, for example, traveling salesman problem. In this video, we are going to solve the traveling salesman problem together. So what is this traveling salesman problem? The problem is that we have several cities, A, B, C, D, up to J. We would like to find a tour that's going to start from a given city, for example, city A. It's going to visit every single city exactly once, and what's very important, that it's going to be the shortest path possible. For example, it's going to be the solution, but there are several ways to connect every city. For n cities, there is n factorial configurations. So we have to visit each city exactly once, and we have to end up at the same city from where we have started. So basically, the tour has to form a closed cycle. But the solution of the traveling salesman problem is the shortest path possible. So the sum of the distances, so basically the sum of the edge weights, has to be as minimum as possible. This is the so-called traveling salesman problem. It is an NP-complete problem. The brute force search would take a lot of time because we should consider every single configuration. I'm not sure whether you are familiar with the factorial operation, but for 1,000 city, for example, it's going to take approximately 1,000,000 years to compute the best solution possible with the help of brute force search. And this is why meta-heuristic algorithms have come to be, such as simulated annealing. It's not guaranteed that it's going to find the best solution possible, so the global optimum, but it's going to have a very good guess, a so-called approximation. And we are absolutely fine with this approximation because the simulated annealing algorithm is going to be much more faster. Instead of, for example, 1,000,000 years, it's going to end up with the solution in seconds or minutes whatsoever. What's very important, it's going to be faster. Okay, it's not going to find the best solution as brute force search, but who cares? It's going to be fast, and this is what's very important. So I'm going to create another project with the name simulated annealing 2, for example, and I'm going to create several classes. The first one is the application from where we are going to test our application. com.myname.tsp, for example, whatever. I'm going to create some other classes, such as one class for the city, one class for the repository. It's going to contain all the cities. So repository. Then we have the simulated annealing algorithm itself. And we have a single tour. It's going to represent a single configuration. So, of course, there are several single tours. As we have discussed, there are n factorial single tours. There are several ways to connect n cities in different configurations. Okay, so the city, it's going to have a private integer x coordinate on the two-dimensional map. And of course, because it is in two-dimension, we have a y coordinate as well. In the city constructor, I'm going to generate some constructor using fields. Okay, so we get this x and y coordinate via the constructor, or we are able to have a default constructor without any parameter, and we generate basically this x and y coordinates. So that's why I'm going to have to cast it. And we have to use the math.random times 100. So what does it mean? We are going to generate a random number in the range 0 and 1. Because it's going to have 0 and 1 in the range, but we multiply it with 100, so it's going to be in the range 0 and 100. And I would like to do the same for the y. Okay, math.random times 100. Okay, Then we are going to have some getters and setters for these x and y coordinates. And what's very important, first of all, it's not that important, but I'm going to override the toString method. It's just going to return with this dot x plus some spacing. Oh, not that. Some spacing and this dot y. Okay? And what's very important, that somehow we have to calculate the distance between two cities. So we have this public, it's going to be a double, so distance 2, and we define another city. Okay, first we have to calculate the x distance. Basically we are going to use Pythagoras theorem. So mass.absolute value of the get x minus the city.getx. It's going to be the distance on the x-axis. Okay, sorry for that, we don't have this parentheses. We are going to calculate the distance on the y-coordinate. So mass.absolute value, the get y minus the other city.get y. Okay, maybe just to be self-consistent, it's going to have the name other city. Okay, and I'm going to copy and paste it like this. And then we just have to calculate the overall distance in 2 dimensions. It's going to be a double. Distance is equal to the mass dot square. This is the Pythagoras theorem. We have to square the x distance times x distance plus the y distance times y distance. If you are not familiar with Pythagoras theorem, there's a good article on Wikipedia. This is how we calculate the distance between 2 points in 2 dimensions. We have one dimension as an x coordinate and another dimension called y coordinate. We just have to calculate the distance on the single x coordinate, then the distance on the y coordinate. Then we have to calculate the square root of the x distance squared plus the y distance squared. Okay, it's quite easy to generalize it to 3 dimensions, whatever. And we just have to return with the distance. So it's going to be very important because the energy function for simulated annealing is going to rely heavily on the distance, because the distance is going to decide whether that given single tour is going to be a good solution or not. If the distance of a single tour is smaller than another single tour, it means that it is a better solution. So that's why this distance is essential for the traveling salesman problem. Okay, then we have the repository. Basically here we are just going to store a private static list of cities. As the cities, for example, we instantiated as a new array list. Okay, and of course we have to import the java.util.list, and we have to define some public static void auth city. It's going to have a city as an argument. Of course, it's going to be void, and we just have to add it to the cities. So cities.add the given city. We have the public city get city according to an index. So we get an index, and we just have to return with the cities.get, and we specify the index. And we are able to get the integer get number of cities. It's just going to return with the cities.size. Okay, so basically this repository with the static methods is quite important because we are going to store every single city in this list of cities. So we are going to have this list of cities, and it's going to contain every single possible city, A, B, C, D, E, F, G up to J. In the next video, we are going to implement the simulated annealing algorithm with the single tour.java class as well. Thanks for watching.